Hello, my name is Emma Karim Adwais, and today I'll be presenting my term project on SplitSmart. It is a collaborative expense sharing application. And throughout this presentation, I'll walk you through the UML models that I created to illustrate how this system works internally. I'll talk about everything from the classes that define its structure to the sequences that show how the users interact with it, to the state diagrams that show how the system manages important processes. My goal is to help you understand not only what the diagrams show, but why each design decisions matter. This is the class diagram for the Split Smart system. While it contains several important classes, the one that I want to highlight is the data management class. The data management serves as the central coordinate of the entire application. Anytime a user performs an action, like adding an expense, approving an expense, managing groups, logging in, or recording payments, everything passes through the management. This class, it's responsible for validating all the data before it gets stored, communicating with the database through the DAO layer, and creating and updating objects like the expenses, the groups, users, and payments. It also makes sure not only authorized users perform certain actions, and it maintains consistency across the system. The expense, group, and payment classes still play essential roles. They store their respective data and represents the main entities in the application. But the data management ties everything together, ensuring that when a user interacts with one part of the system, all the related components update correctly. The first sequence diagram I'll be talking about is the add expense. This sequence shows how the ad expense process works behind the scenes. The interactions begin with when the user initiates the action. It's as soon as that happens, the request goes to the data management class. This is where the system checks, is the user authenticated? Do they belong to the group they creating the expense for? And is the data they entered valid? Once everything is verified, the data management creates a new expense object and fills in the details, such as the amount, description, date, and who created it. Next, the data management communicates with the DAO layer to save that new expense into the database. And finally, the confirmation goes back to the user interface so that the user knows their expense was successfully added. This diagram shows how the system breaks down a user action and processes it step by step to ensure everything is accurate. The second sequence diagram I'll be talking about is the approve expense. This sequence diagram shows how the approval processes work, something that's important in group-based expense management systems. It starts the same way as the user attempts to approve or reject an expense. The request is sent to data management, but here's an additional check. The data management verifies that the user has authority to perform approvals, usually meaning that they're a group admin or designated approver. Once the user's rule is confirmed, the data management retrieves the expense details from the DAO layer. It checks whether the expense is actually in the pending approval state. The approver then chooses to either approve or reject the expense. The data management updates the expense object accordingly to that, and then the updated record is saved back into the database, and the system sends out notifications, usually to the creator or anyone who needs to know that it was being approved. The diagram highlights how the SplitSmart uses checks and controlled workflows to ensure financial decisions are made properly. And then next I'll be talking about the state diagrams. The first state diagram I'll talk about is the expense life cycle. This diagram shows the journey and expense takes from the moment a user starts entering it to the moment it's fully resolved. It begins in the draft state where the user is entering the details but hasn't submitted anything yet. When they hit submit, the expense moves into the submitted state. And if the group requires approvals, it then transitions into the pending approval, where an approver reviews the information. And then if the approver accepts it, the expense becomes approved and is ready for the payment. If they reject, the expense moves to rejected, and the creator can revise it if needed. Once all the payment tied to that expense are completed, it transitions into the paid state. Finally, when the system no longer needs it for active calculations, the expense moves into arches, which keeps the historical record but removes it from daily use. This state diagram ensures that every expense goes through a clear, structured workflow and avoids inconsistency in group balances. The next state diagram I'll talk about is the password checker. This diagram explains how the SplitSmart checks a user's password during login. Everything starts in the start state, where the system is simply waiting for the user to enter their password. Once the user types it in, the system moves into the checking state. It is in that state, it looks at two things: how strong the password is and where it actually matches the stored password for that user. And then based on that check, the system may classify the password as weak, medium, or strong. That is mainly the feedback for the user. And then if the password doesn't match, the system enters invalid state and lets the user try again. And if it does match, the system moves into the valid state and accepts it, meaning the user had been authenticated and can access the application. This diagram shows how the SplitSmart maintains security while giving helpful feedback during the login process. The next state diagram that I'll talk about is a notification status. So this state diagram shows how the notifications move through the SplitSmart system. Notification begins in the created state whenever something important happens, like an expense being approved. And then from there, it moves to the queued, where it waits until the system is ready to send it. And then once it's actually delivered to the user's device and sent, after it was being waited to be sent, it enters the delivered state. And after that, one of the two things happen. If the user opens the notification, it moves to red, and then if the user ignores it and expires, it transitions to expired. Or if the user read it and then the time has already passed, the expired time, then it's gonna expire after some time if the user that already read it. So this model helps the system track communication and ensuring users stay informed about the group activity. Then thank you for watching. I'll move on to the project itself and shows the class diagram in more details. Hello, this is my class diagram in the project, and I'll go in details to explain each part. So for the main part, we have the main class in the middle, which is the data management. This is gonna be that's gonna serve the entire application, and each other classes will depend on that class. It has the authentication and then managing expenses and then managing the users and the groups. And then from that, this is what's gonna make the use cases more efficient. So to tie it up with the use cases that I did, we had some use cases for adding in expenses, which the flow of events will go from logging in, authenticating, which will go from the data management and then go back, then go to the expense to add in the new expense that the user wants to enter. Some of the attribute in the expense class is the amount, date, description, and the ID, and then involved groups and the user and the receipt image. And then from there, it's gonna save it up as an expense and then go back to the data management to approve that expense if the admin is an approver, which will be set in the authenticating function. And then from there, we have the balancing adjustment that's connected to the data management as well. And then we have the user view that's gonna either display the panel that will let the user either choose to add an expense or approve an expense if the user is actually an admin, or create a group, manage a group if the user is admin as well. So we have another function in the user view is logging, which will let the user log in and then authenticate if the user is actually a regular user or an admin for the whole system, which will let them have more authorities over the other users. And then we have another function that's log out. And then from there we have the user view. They can even view the group that they're in, which have some attributes like the group ID, group name, and then the members of the group. And then each user will have the option to view the payment that they had previously or that they have to pay for their new balances. And then some of the attribute for the payment are amount, date, payer ID, payment ID, and the receiver ID. And then another class that's connected to user view as well is the notification, which will include the date sent and then the user ID and notification ID, and then the message that will contain the warning or the notification about a certain stuff that happens in the software. As you can see, all of the classes are connected together in a more cohesive and secured way. And then we have some of the entities that are relating to each class that we have, like the expense user, which will have the expense ID, user ID, and the percent. And then we have the receipt, which will have the receipt ID and the store name. And then for the expense, it's just the attribute for adding an expense. And then for the user group, it's more related to how to create a group and what's related to that group, to the group ID, group name, and member ID. And then for the user, it's their entity as a user that will use the software. It has their ID, name, email, address, and password. And then for the notification, we have another entity that's notification info, which will have all the attributes in the entity. And then for the payment, we have either they can, we have some attribute that must be entered for the payment info. It's some of them are the payment ID, payer ID, and then the amount, and then the payment date, group ID, and then status. And then for the group, we have two entities, which can be like the group info and then the group membership. The group info are the regular entities like the group ID, group name, and then the group membership is relating to the membership of the user to the certain group and how all of them are connected. And then this is the class diagram uh, that was used to create some of the use cases. Which some of them are just creating approving expenses, and then how to create groups, managing groups and with the users. And these help me a lot to distinguish the use cases and how they're related to the actor, which can be the user, admin, or the approver. And then going to the some of the sequence diagrams in more details, we have the add expense, which will start from the user. And then when the user logs in, it goes to the user view, which will go to the data management to authenticate. If it's authenticated, then it goes back, and then the user would choose to display the panel. And then for the that panel, it will allow them to either to add expense approve or other states as well. But then for the sake of this diagram, we will the user wants to add an expense, and then this is when the expense starts, and then it goes back to the data management to check to manage the groups that's related to the expense. And then it goes from the group to checks the group members using the controls of the user group, and then goes back to the expense, which will update the amount by using the balance adjustment control. And then from there, it will just go back from the data management to the some entities to add the expense and then update the user amount. And then the other state diagrams, sequence diagrams that we have is the approved expense. First goes the same way that it went from the add expense. The approver will log in as an approver, and then they will have to authenticate using the data management. Then once they're authenticated, they choose to display a panel, and then from there they choose expense, which is a approving an expense, and then it goes back to managing the expense from the data management, and then from that it will use the balance adjustment to check the amount, and then load the tables in the expense, the entities in the expense, and then goes to the entity of the expense to approve the expense. And then it goes back from the entity to the data management to manage the expense user once the approver already approved that expense. And then we'll go to the state diagrams that we have. We said the first thing that we were talking about is the expense lifecycle. So first it goes from the initial state, and then once the user creates an expense, and then starts entering them, the draft expense has some attributes in it, such as that created by is complete to know if the expense is completed entering, and then the expense ID, and then once submitted, and then the await approval and the group ID and the submitted date has been filled, it goes to a pending approval, which will decide if the expense will be approved or rejected. So for the approved state, it has some of the attributes like the allocated balance, which is a double, and then approved by date, and then the rejected. We have some of the attributes rejected by the date, and then the rejection reason. And then after the expense is approved, it goes to the record payment, and then once it's paid, we close the expense and it saves it as an archived, which has some of the attributes is editable if the user can edit, and then the tentation period, and then from there it goes to the final state. And then the other state diagram is the password checker. So from the initial state, we enter a password and it goes to the start state, which will have a session ID awaiting for the user to enter it. And then after that, it checks whether the password is weak, is the password medium, and then is the password strong. And then for the weak, it's gonna allow it to retry, and then checks for the strength level, and then some suggestions will allow the user to retry, and then goes to the medium, which it will suggest to the user to contain some numbers or symbols, and the length of the password uh, that needs to be entered by the user. And then from there, it will allow to the user to try again to have a strong password, which will have the entered value and then the length, and then another recommended that's even stronger. And then after that, it's being approved. Um, the system approves it as a password. It gets accepted, and then some of the attributes are the password hash verified, and then the session token, and the user ID that entered the password. And then another state diagrams I'll be talking about, the last one, is the notification status. So from the initial state, um, we move to the created state. And then this is whenever something important happens, like an expense being approved. It has some of the attributes are created time, notification ID, and the recipient's user ID. And then once being drafted, it goes to the queued, and that's where it will wait until the system is ready to send it. Some of the attributes are queue position and the try count, and then it will wait in a queue to be sent. And then when it's time to be sent, it will send the notification. Then after it's then this sent state, some of the attributes are device ID is acknowledged and the user ID. And then once it's already sent and the user got the notification, it will be in the delivered state. It will have some of the attributes are delivered time, delivery method, and the device ID. And then once the user read it, it will go to the read state, and then some of the attributes in the read state are interactions type, opened on device ID, and read time. And once the notification um, has expired to the certain set time, it will go to the expired state. And then some of the attributes are cleanup scheduled, expired time, and is it actionable. And then from there we go to the final state. And that's it for the our uh, software. Thank you so much for watching my presentation. These diagrams helped guide the design and the structure of the SplitSmart, and together they show how the application handles data, user actions, and the system workflows. Appreciate your time, and I would be happy to move on with this software in the future. Thank you.